In this chapter, we're going to take a look at Newton's third law. Very easy to state. For every action, there is an equal but opposite reaction. Now, this really stems from a different form of Newton's third law that says for every force, there is an equal but opposite force. And this is the one that's going to be relevant to what we're studying right now. So, for example, if you push against the wall pushes back on you. And one of the places that is a little bit confusing is people don't realize that an inanimate object like a wall can really push back on you. But indeed it really does, as we'll see in a couple of more examples. One other thing you might think about is if you've ever pushed on the edge of a table really hard, and you can feel the table pushing back on you, but even if you look at your palms of your hands, you can sometimes see creases that were as a result of the table pushing back on you. Okay, so some examples. Walking is a good example. So as you walk, you apply a force against the ground, and the ground applies an equal and opposite force back on you, and that propels you forward. Swimming is another example. You apply the force on the water applies an equal and opposite force back on you, again propelling you forward. Another example is shooting a rifle. Probably many of you have shot a rifle and know what I'm talking about, but if you haven't, when you do shoot a rifle, there is a distinct kickback. The rifle sort of accelerates backward into your shoulder. Now this is a direct result of Newton's third law as well, because the rifle applies a force on the bullet, and the bullet applies an equal and opposite force on the rifle. However, the bullet accelerates at a much greater rate than the rifle does, and that's because they don't have the same mass. And the mass of the bullet is a whole lot less than the mass of the rifle is, and so therefore that experiences a much greater acceleration. Another example of this is space travel. A rocket in space, can it accelerate? Yes, it can. Even if it's in deep space and there's no matter around, it can expel a gas out of the back of the rocket. By doing that, the expelled gas applies an equal and opposite force back on the rocket, propelling it forward. Now, one thing to remember about this Newton's third law is that these forces act on different objects. So what I mean by that is, let's take the walking for example. You apply a single force on the ground. The ground applies an equal but opposite force back on you. Now there are two forces here. They're both equal. However, they are on different objects. The one force is applied on the ground. The other force is applied in the opposite direction back on you. So there's only one force on the ground and one force on you. Now there's going to be some more detailed explanation of this in your textbook that you'll see.